So what we're going to talk about today, just as a refresher, is some of the language that we use when we talk about math. Some of those words, because tonight's homework is all words. You know, it's not numbers. Because although numbers are powerful, they only have meaning when they are found in context of a word problem or an application problem. The good thing is you don't have to solve any of these problems tonight. You don't have to get an answer. You just have to be able to set it up, okay, to get started. We're not going to do the solving. We're just going to do the setting up. All right, so I have 3 things I want to review with you. All of these we've learned before, probably going back to pre-algebra, Algebra 1, and Algebra 2. The first thing I want to talk about is the concept of less versus the concept of less than. I find that those 2 words, by adding the than on it, it throws people off, and all of a sudden it gets confusing. Generally, these mean subtraction, right? Less is going to be subtraction, but in subtraction, order matters. It matters whether you do 7 minus 3 or 3 minus 7 because you get different answers. With addition, it doesn't matter, but with subtraction, it does. Thanks. All right, so let's talk about what the difference between that is. Okay, so if you have 7 less 3, or if you have 7 less than 3, those 2 things mean something different. So 7 less 3 is the traditional subtraction. That's 7 minus 3. That's just the order that it goes in. But when you have 7 less than, now 7 is the smaller part because it's less than 3. And so the order of the subtraction switches around, and we now have 3 minus 7 instead. And so that makes a difference. And so some of the example problems you might have, they're not going to be that easy, but it might look like something like this. It might be 4 less than 37% of a number. And then your job is to make an expression out of that, to translate that into mathematics. So a couple things you need to look for. Well, one is the idea of it's less than, and so it's 4 less than, which means that the problem is going to be minus 4. It's not going to be 4 minus. It's going to be something minus 4. The next thing you got to remember is what to do with a percentage sign, right? So in percentages, when we take it away, which direction do we move the decimal? Okay, so I'm going to move this. It's going to be 0.37. But that's not the end of the answer, the problem either. It's not just 0.37 minus 4. The percentage needs to be followed by a number. We don't know what the number is, and so when we don't know the number, we replace it with a variable, so 0.37x. Every percentage should be followed by a variable. Okay, a percentage should never hang out there just by itself. It's always a percentage and then some variable that you choose. I don't care what letter you pick, just pick a letter. All right, another example you might see under that topic might be something like 7 less half a number. Okay, well this time it's not less than, it's just less. And when it's just less, then it's 7 minus, not minus 7. And it's minus half, and again, it's of a mystery number. So you could use the letter N to stand for number, or A, or X, or whatever letter you want. Pick your favorite letter. Okay, so that was one thing I wanted to talk about, was the difference between less and less than. Okay, the second thing I want to talk about is the words each, per, and percent. Okay, the words each, per, and percent. All of these words indicate that they're followed by a variable. anytime you have those words showing up in a math expression, it means there needs to be a variable included. All right, so an example might be a down payment of $500 plus $125 each month. All right, so then how do you make that into a math expression? So sometimes people will say, oh, 500 plus 125, and then I'll get this as an answer. I'll get 500, ooh, that's bad. I'll get 500 plus 125, and then it will stop. Like, sweet, 625, awesome. That's not the end. It's not just 500 plus 125. It's 500 plus 125 each. Okay, each. And so that means that 125 has to be followed by a variable. So each what? Each month. So maybe we'll use M for month, or we'll use X. So it's not just 500 plus 125, end of story. It's 500 plus 125 ongoing for every month that occurs. Okay, here's another one. A deduction. Okay, a deduction of $12.83 per paycheck. All right, I don't know if any of you have a job yet, but you think you're making $11.25 an hour. So you're like, okay, $11.25 an hour, and I work this many hours, my paycheck should be this, and then your paycheck's less because there are deductions, there are taxes, there are withholdings. Okay, so a deduction of $12.83 per paycheck. So how would you write that? Well, deductions are negative, so this is a negative number. $12.83. But then because it says per, you need to include a variable after that to indicate that this is going on over and over and over again every paycheck. It's not just a one and done thing. And so you could put X, or you could put P for paycheck, or whatever variable you want, but that word each. All right, so then how about this? Tax of 9.25%. Tax is tricky. Percentages are tricky. All right, a couple things about percentages. We already talked about moving the decimal. But now we also talk about adding a variable. A percent also needs a variable added onto it. And percentages also always start at 100. All right, so a couple things about percents you need to know. Always start at 100. Remember to move the decimal. And the last one, and add a variable. All right, so what do we do with this? If you're on tax, if you have a tax of 9.25%. All right, you always start at 100%. So this is actually 100% plus the tax. Tax is an increase. So it's 100% plus 9.25%. So you always start with 100. If it's on sale, then you start at 100 and you go down. You subtract. Okay, but tax of 9.25%. All right, so that equals 109.25 when you add those two together. Then you change that into a decimal, and a quarter, just like a coin, that's a quarter, is 25 cents. So this is 109.25. Now we have to move that decimal. So we're going to move that decimal 2 places to the left. So 1.0925. And then the last thing to do is to remember that you have to add the variable here. What that variable represents is the original cost of whatever you're being taxed on. Okay, are you being taxed on a purchase? Are you being taxed on your meal that you ordered? You know, what was the original value? That's what that X, that variable, stands for. Okay, the original value of the thing that you are buying. All right, last one. A discount of 17%. Okay, so this isn't a tax now. This is something that's on sale. The rules still apply though. You always start with 100. So this would be 100%. Discount, so that's a subtraction, 17%. So it's a subtraction first. Then 83% is what we have. Then we move the decimal, so 0.83. And then we remember to add the variable on the end, maybe P for price or whatever. Okay, and that again represents the original cost, okay, the original price tag of what you're working with. Okay, so I wanted you to review the words more is addition, less than, each, per, and percent. Those are the 5 things that are going to pop up in your homework tonight. So your homework is going to be a lot of this. Okay, here are the words. Turn it into a math expression. But you're not solving, you're not getting an answer. Okay, you're just going to stop at getting the expression. And then again, feel free to check those answers in the back of the book. Then I'll give you the even ones when you come to class tomorrow.